Hi and welcome back to a new video. We just started shipping out the first batch of the WireView Pro II. We had a small delay, but today I want to give you a first look on the current state of the firmware and also a first look to the software that is not released yet, but will be released soon. And also some things that I've figured out already with the WireView Pro II with its help, and some things that are again quite concerning when it comes about the 12-volt high power connector. And that might also be helpful for you once you got your device and you maybe want to start debugging some cases that look like current imbalance. Endorfy expands the popular ARC series with the ARC 700 white RGB with its well-known features, but with white color. The Ultra Mesh front delivers maximum airflow to keep even the largest high-end graphics cards perfectly cool. For your CPU, the case supports 360 radiators at both the front and top. It also features clean cable management, USB-C connectivity, and a tool-free design that makes building your PC easier than ever. Check out the link in the description for all details. The small delay we had in shipping out the WireView Pro II was mainly caused by the Christmas holidays, so those 2-3 weeks are quite difficult when it comes to receiving parts, shipping them out. But we now started shipping out the first batch. It will take probably like 2 weeks to finish the first batch and have all of them sent out, and then like 1 or 2 weeks later we will start shipping out the second batch. So that's going to be around end of January, and we also updated everybody that pre-ordered the device via email already, like I think 1 or 2 weeks ago, so everybody knows what is going on. I'm expecting very good availability, that the device is actually in stock early February or mid-February, but if you would pre-order now, you would still be part of the second batch. I already showed it in the previous video, but I just want to mention it again. The WireView Pro II comes in 2 versions, so it's normal and reversed. That just comes how your 12-volt high power connector is sitting on your card. So for example, this is an RTX 4090 that has a normal orientation. That means that the small 4 pins you can see right here, they are oriented upwards. And then you can see this small notch right here, the small thing that is sitting on top of the connector where the latch clips into, and this is the normal orientation. For everything else, where this is flipped by 180 degrees, so you would have the nose facing upwards and like the small pins downwards, then you need the reverse edition. That is, for example, the case for Gigabyte cards right now, or also for the Asus models. That's how the retail device looks like. You can also see that the current revision of the PCB is revision 5. One thing that we changed from the previous prototype is that we also added this patch on here to protect the pins of the bottom 12-volt high power connector. So in case it touches something on your GPU, that you can't short anything. And we also changed the screws in the front of the fan. So they are using a hex. So they're using hex screws to just look a little bit nicer. This is how it looks like mounted, and for mounting I would generally recommend that you first plug in the PSU cable into the WireView Pro II and then plug everything together into your GPU. You might need a bit of extra force to plug the WireView Pro II into your card. Just make sure that is absolutely important, that it is fully plugged into your card. Just check, maybe take a light and look from the side that you can see that the connector is fully plugged. That is absolutely important. Now I quickly want to run you through the views. That is the main view that you can see right here with multiple elements. Top left you can see the bar chart that is showing the current per pin. Also going from 0 to 10 amps. So those are pin 1 to pin 6 or pin 0 to pin 5, depending on how you look at this. And then also the bottom left is a bar chart that shows the total power consumption assigned with the number next to it. Then on the right we can see the fan that symbolizes that the fan is currently spinning at 30% fan speed. And then on the top right you can see temperature, which is currently set to detect the max temperature, which is the in temperature sensor, so that's the bottom cable, with 57 degrees Celsius, and sense shows that a 600 watt power cable is present right here. Now if you do short clicks, you can cycle through the views, and with long press you can enter the configuration mode of the individual views. So there you could also change the current scale, which was 0 to 10. You could also set this to 5 amps max, for example, if you only have like a 5070 and you want to see this better, then this would make sense. Or also if you have a shunt modded card, for example, you could increase this to 15 amps or like 20 amps if you wanted to. And the same goes for power scale. Temperature source you could also manually select instead of max. If you do long press, switch over, you could change this also to like TS1 or TS2, which are the external sensors. I will keep this at max. And then you could also change if you want to have this shown in the so-called cycle mode, which is currently not activated. But the cycle mode means that it will automatically cycle through the views, and then you can select each individual view if you want it to be seen in the cycle mode or not. I will keep this at yes. And you can simply save it. The second view is what we call the simple view. This is inspired by the previous WireView, so you just have all the values, the max peak values, just simplified on one page. The third view is probably the most important, that displays the current per pin, and also on top right, the total current across all of the 6 pins. And then you can see the 6 pins with its individual current. Here you could take a look at the temperature sensors. Currently, I did not connect the external temperature sensors. Then we also established a status page, which is showing what kind of firmware you are running, and also if USB is connected or not. And as you can see on the bottom left, if you do a long press, you will enter the global settings. Here you can configure basically everything. Also fan control, for example, which is set to auto, and I would also recommend to leave it there, because if the device is running hot, then you should use the fan that is built in. Then you have all the individual limits underneath. So that would be the current limit, power limit, or temperature limit. And all of these are fully configurable. And default values are 10 amps for the current, 660 watts for the total power, and 80 degrees Celsius for the temperature. So those are the predefined values set by us. But you can always change them if you want to. So that might be needed if you're running a card with lower power, like a 5070 or a 5080, or if you are running, for example, a card that is shunt modded and you want to run higher limits. So you just long press, enter this, and here you can see you can increase the limit to whatever you want to. You can also set this, for example, to 9.5 amps if you want to. Then just long press, then it applies the limit. We also decided those limits on purpose, and also decided that you are free to configure your WireView however you want. You can, in theory, run it full out of spec if you are running a shunt modded card, because I know a lot of people in like overclocking scene, overclocking industry, and there are a lot of people that want to run their card on purpose out of specs, and you can do so if you want to. So you can set it, for example, to 13 amps, 15 amps, whatever you need. Once one of these 3 limits is reached, you get an audible alarm and also visual on the device, and then you have the option to also do auto shutdown. For the auto shutdown feature, you will have to connect the Y-splitter cable between the WireView and the power button connector on the motherboard. So typically, if you would have your case and you have the power button connected to the motherboard, you would take this Y-splitter cable and connect it in between the motherboard and the case. So the WireView would go in between there, so you can still use the power button on the case, but the WireView has access to the power button to do the auto shutdown if you want to. I'm also aware that some cases use this combined connector that has like power button reset and some LEDs, for example. I currently, unfortunately, don't have a solution for this, so you might have to build your own adapter or connector. As you probably know, the WireView 2 comes with an extended warranty, and this extended warranty only counts for the predefined values. So if you run your WireView, for example, on 13 amps constantly, like a shunt modded card, this would not be covered under the warranty. And you can find the warranty terms on the Thermal Grizzly website. You can also test the alarm if you want to by artificially lowering the values. For example, current limit, I just changed it to 7 amps, where we know that a 5090 under full load will have something like 8 to 9 amps. We just save it, and then we should be able to trigger the alarm under load. I did not connect the Y-splitter cable for the moment because I do not want my system to be shut down by the WireView, just for testing reasons. Otherwise, I would have to connect it here and then connect it to the power button of the motherboard. And we'll just start Firmark now. You can hear it and see it. I will just disable it for a moment. So after exceeding the value for 10 seconds, then the alarm will go off, as you could see. And then once you hit the button, it's resetting. But obviously it's still exceeding the artificial value we just set, so it will trigger the alarm again after another 10 seconds. A couple of days ago, I was testing over 10 WireViews because I just wanted to verify the first finished samples to see if everything is fine, if we missed something, right? And then I straight noticed something, why it's just nice to have this device. The thing is that the WireView is obviously just one part of the chain. So it starts all the way from the PSU to the cable, the connection in between, going to the WireView, so the connection between the cable and the WireView, and then essentially the connection between the WireView and the card. But every single connection, every single part can contribute to the issue and can also be a fundamental part of the issue. I used exactly this cable, and on a few of the WireViews I just noticed that the current distribution was not exactly where it should be. So what I noticed is that there's just like tolerance on the cable, right? And if I play around with the cable, like just pay attention to the first pin and the way it's measured. So now I push it all the way in, and that should be good. If I pull it out a little bit, you can see immediately how it drops down to like 6 point or like 7 point something because of the contact resistance that is changing. Pushing in, it's good. Pushing this out, it drops down. And that also happened to the right pin right here. So you can just change this by pulling. And here you can see it on the left that it's like 6 point something amps, and then on the right it's 9 point something amps. And here we get the current imbalance warning. And then you're thinking, okay, so is there an issue with my WireView or with the graphics card? But in this case, it was just the cable itself. So I can just cancel this, and I'm pushing them back in. And there you can see the current imbalance is mostly gone. And this just showcases once again how difficult this connector is. And that it might not only be the connector from the WireView to the graphics card, but the entire chain can be the issue. So once this happens to you, that you see this current imbalance, it is absolutely important to track down the entire chain. That you try to reseat the connector into the WireView, into the PSU might also be needed, push the pins in and try to fix it. Because it might not only be the connector directly from the WireView to the card. And it still absolutely blows my mind because, you know, it is just a normal cable and all I'm doing in testing is I plug it in and use it. And there's such a huge tolerance in what I can see from like 6 amps to 9 amps by you're just plugging it. And it just absolutely blows my mind how in almost 2026, when I'm making this video, once released it's 2026, NVIDIA is still ignoring the issue. And I can tell you, once you have a WireView, a lot of people will see exactly this. That they plug it in and they will have current imbalance and they will have to track down where it comes from, reseat cable. It's a mess. And this is a preview of the software that is not fully done yet. It will be released soon. So on the left you can again see the per pin current. You can see the total current in the middle, power consumption, voltage, and also the temperatures that are being tracked on the bottom. You can also have settings that allow to export the information to hardware info, auto start, or also start minimized. Using logging, you will be able to access the memory on the WireView Pro II to access the logging data, so this is not completed yet. And if you click on monitoring, you can also access the live information out of the WireView and display it in a chart that you can also fully configure. So you can change the interval, you can change the Y and X axis depending on what you want to do. You can access all the information from voltages, currents, temperature and everything, and display it in a chart like you can see it right here, where the thing that is in the center is the current across the 612 volt pins. So you can see it's going somewhere between 7 and 9 amps at the moment. And then on top you can see the total power draw, which is currently listed in green. So much about the first firmware version and also the first look into the software and also issues that I encountered with the connector once again. So that is something that's going to be absolutely interesting once the first of you receive the WireViews, and then I'm curious how many issues we will be able to find and hopefully prevent further issues on burned graphics cards. So thanks for watching, Happy New Year and see you next time. Bye bye.